Hello everybody and welcome back. Today we're going to keep talking about circles, and we are going to specifically be talking about when two chords meet inside of a circle. What special things we know about how long those chords are with relationship to one another. So the date I'm going to put on this lesson is April 21st. It's Tuesday the 21st, 2020. And we are going to talk about how long these chords are when we look at a picture like this that we see here. When we have two chords inside of a circle that are crossing one another, the neat little relationship that exists is that the product of the parts of one chord is equal to the product of the parts of the other chord. So to put that a little bit more simply, if we look at one chord like this one here, this chord is broken into two parts. There's this first part here, and then a second part here. So one part is labeled A, and the other part is labeled B. Then when we switch our focus to the other chord in the same picture, we have this chord here, where one part is labeled C, and then the other part is labeled D. So those chords are meeting at one point in the middle, and the relationship is that if I multiply A times B, that will equal what I get when I multiply C times D. That's the whole rule. Part times part of one chord will equal part times part of the other chord. So for this particular example, that would mean that A times B will equal what I get if I multiply C times D. So, of course, we can take problems like this to all different levels of difficulty depending on how messy those labels are, and then having to solve for a variable and sometimes plug back in and that kind of thing. So here goes. We're going to look at a couple of examples. So for the first example here, we have BF equal to 6. So F is this point of intersection in here. So BF is labeled with a 6. And FE, the other part of that same chord, is labeled with a 10. Then they tell us that DF, this part in here, is labeled with a 5, and FC is labeled with an X. So what's that relationship that they just told us about that we can use when they ask us to find the value of X? Well, part times part of one chord, so if you want to say 5 times X, will equal what I get if I do part times part of the other chord, so 6 times 10. In other words, I would have 5x is equal to 60, and then you would have to divide by 5. And when you do that, of course, x will be equal to, what will that give you? 12. And that's it. They didn't ask us to do anything else. Sometimes they will ask you to go back and find, like, say, the whole chord from C to D. So just make sure that you're being careful about what the question is asking you for, and make sure you answer the question that you are being asked. All right, we're going to take a look at one that gets a tiny bit more involved than that. So let's take a look at number 2. Again, the basic concept is always the same. It's part times part equals part times part. So looking into that here, we have ZP. This piece in here is labeled with an X plus 3. We have PY, which is this whole piece here. That's labeled with an X plus 9. WP over here is labeled with X. And PX over here is labeled with X plus 4. So the first thing they ask us to do here is find X, and then they want us to find YW, which will involve a little more plugging back in. So we'll start with our basic rule, which again is part times part. So I'm going to say X plus 3 times X plus 4, because those would be the two parts of this chord here. And then I'm going to switch focus to the other chord and do part times part on that chord. So that would be then equal to X times X plus 9. And then you have to go ahead and solve that. So if you want to practice your algebra skills, shut this off for a minute, try it, then come back and check. If you want to go with me as I go step by step, feel free. When you go to multiply these two together, that's FOIL or double distributive property or the box method, whichever one you remember and like to use the most is fine there. This one is just simple distributive property, so that was a little bit easier. So let's say here, I'll show you double distributive. You can also go ahead and make the boxes off on the side and do it that way. X times x would give me x squared. X times 4 would give me 4x. Then for the other one that has to be distributed, 3 times x would give me 3x, and 3 times 4 would give me 12. I then can combine like terms here, and my left side says x squared plus 7x plus 12. Now, what if you did this flip-flopped, and this is on the right side of the equation? That's fine. It doesn't matter. Now I'm going to deal with the other side. I, on this side, just have a monomial, one part, multiplied by a binomial, two parts. So over here I can use distributive property, but I only have to do it once. So that's going to give me x squared plus 9x. So this is my equation. And now I have to solve this equation. So one of the nicest things that could possibly happen actually occurs here, and that is if you start to move things over to get like terms together, what you should see right away is if you subtract an x squared from both sides, this equation is no longer a quadratic. All the x squares turn out to be 0. So we have 7x plus 12 is equal to 9x. And then to finish this problem, all we have to do is subtract the 7x from both sides. So we have 12 is equal to 2x, and then divide by 2, so x is equal to 6. So my first question was to find x. X equals 6 is my first answer. The second part of this question asked me to find yw. So if I go back to look at where yw is, please realize that yw is what you get if you add together yp and pw. So now I have to go back and substitute in. Yp was x plus 9. So that would be 6 plus 9, which is 15. And then pw was x, so that of course is just 6. And what am I going to do if I want yw? I have to add these together. So 15 plus 6, grand total of 21. So my second answer, second part to the problem, yw is equal to 21. And of course we would just leave these with the numbers because we weren't given units. If we were given inches or feet or meters or whatever, then we would label accordingly. All right? So that is basically the entire concept behind this lesson. As you see, it could stay at a very simple question like number 1, where it's just nice numbers, or this second problem is actually the same level of difficulty as far as the concept goes. It's just that it brings in a lot more algebra review in order to get through the problem. All right, so I have one more problem for you like this. On the second page, there's only one problem, and we're going to go ahead and try that. So again, if you want to stop this, go take a break, try the problem on your own, and then follow my explanation, feel free. If you want to follow through, here I go. Okay, so now for the problem on the back, here's the story. We're going to start by labeling things that were given to us in the picture. I'm sorry for a little bit of a mess here on mine. I made a mistake and I had to go back and fix. So here goes. CD equals 10. So that's this entire segment here from C to D. The whole chord is equal to 10. And then they tell us that CE is equal to 4. So what that will allow me to do is if this is 4 and I know the whole thing is 10, then I can figure out this other part of this chord by just doing 10 minus 4, which is 6. So now I have both parts of this chord labeled. They are 4 and 6. And then they tell me that EB is 6 times more than EA. So EA is going to need a label. I'm going to call it X. And EB would be 6 times that. So this would be 6X. Okay, so now I'm back to that same rule that we talked about on the front, where I am going to do part times part equals part times part. In this problem, that means I'm going to have 6x times x is equal to 4 times 6. That means when I work this through here, I'm going to have 6x squared equal to 24. When I'm solving a problem like this, I can divide by that coefficient that's out in front, so x squared is equal to 4. And then normally I would have to worry about the fact that x squared, well, this could be negative 2 squared or positive 2 squared, but since we're talking about a side measure in a figure, I don't have to worry about that. So x will just be the square root of 4, which is 2. Now, they asked me to find two things for this problem, like the one that we talked about on the front. First thing they wanted was AE. So AE, of course, was just labeled with an X. If I look over at my picture, AE was X. And so I can just make that equal to 2. And the other piece asks me to find AB. So again, with a problem like that, I have to realize that means all of this together. So in order to get AB, I have to take AE and I have to add EB to it. So AE we just figured out was 2. EB is supposed to be 6 times 2. So that means I have 2 plus 12, and my grand total there would be 14. So those are my two final answers there, 2 and 14. And that's the whole lesson. All we had to do today was learn this one basic little fact about when two chords are crossing in a circle, that the product of the parts of one is equal to the product of the parts of the other. You saw a couple of practice problems here with that, and there'll be a few more on the homework sheet. All right, hope you have a great day. See you tomorrow.